In this video, we're going to look at the inverse of a matrix. The problem is to use A inverse to solve the following system. First thing we could do is write this system in its matrix form. AX equals B. A represents the coefficient matrix. So pulling out the coefficients from the system, we've got 2, 2, 2, 1, 0, 2, 1, 0, 3. X is a column vector which represents your variables, so x, y, z. And on the right side we've got a column vector consisting of the constants. So there's the matrix form of our system. Now the idea is that x, the vector which contains our variables, is equal to A inverse times B, and this will be true provided that the inverse matrix actually exists. So let's say provided that A inverse exists. So what we'll need to do here is find the matrix A inverse, and then we'll be able to use this formula here to solve the system. Now in terms of finding the matrix A inverse, what we'll do is we'll set up our coefficient matrix, and beside it we'll write down the identity matrix, and we're going to perform Gauss-Jordan elimination to create the identity matrix on the left side. Now, as we undo the matrix A, what we're building up on the right side is the matrix that undoes A. So we are building up A inverse on the right side. So we'll go through this procedure here, we'll find A inverse, and then we'll come back to this formula at the end of the problem to find x, y, and z. So let's copy out our coefficients on the left, and on the right we will write out the identity matrix, and then we'll get going with our Gauss-Jordan elimination. I'd like to get a 1 in the upper left. Probably the easiest way to do that is just to swap the top two rows. So I'm going to circle this 1 here, and we're going to use that to eliminate the other entries in that first column. We'll do row 2 minus 2 times the pivot row, and we'll also do row 3 minus our pivot row. Doing row 2 minus 2 row 1, we will have 0, 2, negative 2, 1, negative 2, 0. And then in the bottom row, doing row 3 minus row 1, we'll have 0, 0, 1, 0, negative 1, 1. So not a bad idea to check your work at each step, and that all looks good at this point. All right, so we've completed the first column. We're now going to move down and to the right from our previous pivot. We're moving down to this 2 right here, and that's going to be our pivot for the next step. So let's take row 2 and divide through by 2. On the right side we'll have half, negative 1, 0, and the other 2 rows are going to stay the same for this step. Now to complete column 2, normally what we would do is use this 1 to eliminate the other entries in that column, but fortunately those other entries are already 0, so there's nothing further to be done with that second column. Now we move down and to the right. This position here is going to be our next pivot, and fortunately that's already 1. So again, that saves us a little bit of work. We're now going to use that 1 to eliminate the other entries in that third column. So we'll need to do row 1 minus 2 times our pivot row, and we'll do row 2 plus our pivot row. All right, so row 1 minus 2 row 3 is going to give us 1, 0, 0. And then on the right side we'll have 0, We will have 1 plus 2 gives us 3, and we'll have -2. Right, in the middle row, if we add rows 2 and 3 together, we've got 0, 1, 0, half, -2, and 1, and the bottom row will stay the same. So just double checking our work at this step. All right, everything at this point looks good. So we've now created the identity matrix on the left-hand side, and that tells us that this matrix sitting right here is A inverse. It's the inverse of our original matrix A. So we'll use this A inverse together with this formula here that we wrote down previously to now solve our system. So we said earlier that X is equal to A inverse B. That's provided that A inverse exists, which it does in this particular problem. X is a column vector consisting of our variables, so that's X, Y, Z. And I'm going to copy down the matrix A inverse that we discovered on our previous screen. So it was 0, 3, -2, half, -2, 1, and 0, -1, 1. That gets multiplied by B. Now let's remember B is a column vector which contains the constants for our system. So we said earlier B was the matrix 16, 22, 31. So now in order to solve our system, all that remains is just to do this matrix multiplication here. So we're going to do our multiplication in the usual way, just taking the dot product of the rows of the first matrix with columns of the second matrix. So as we do our dot products here, we're going to produce 4, -5, and 9. We can take a look back at our original system and we can check that yes, this satisfies the first equation, satisfies the second, as well as the third equation. So we do indeed have a solution to our system.